So equal vectors ante their magnitude is same and their direction is also same. 1 minute video stop ayindina. Right. Their magnitude is same, their direction is also same. So for example, this is vector a bar and this is b bar. I say that a bar is equal to b bar. So these two vectors are equal vectors. Okay. Two vectors are said to be equal if magnitude and direction is same. Direction is same. Okay. Next we have parallel vectors. The diagram, you can draw the diagram like this. Okay. Next, parallel vectors. Parallel vectors. So their magnitude may or may not be same, but they are parallel. Okay. Next, anti-parallel vectors and how we will be having this anti-parallel vectors. Anti-parallel angle between both the vectors is 180 degrees. Okay. That means one vector is like this and another vector is like this. Both angle between both the vectors is angle between a bar and b bar is, this is a bar and this is b bar, and b bar is 180 degrees. Okay. Note down this. We are discussing the kinds of vectors. Yesterday we discussed unit vector, null vector, and what is this? Equal vectors. Next, parallel vectors. So angle, what is the angle? Angle between both the vectors is 0 degrees. Okay. Right. Equal vectors means magnitude and direction also should be same. And if there is a force like this, 4 newtons force, another force is like this, 4 newtons, I say this vector is not equal vector to that because direction is different. One force may be giving the acceleration in one direction, another force gives the acceleration in a different direction. Okay. So vectors means direction is also important. So if someone asks you to push a table, you will be asking in what direction I have to push it. Okay, in what direction the force needed to be applied. If the force has a different direction, these two vectors are not same, not equal vectors. So magnitude, if only magnitude is equal, they are not said to be equal vectors. Both direction and magnitude should be same. Okay. You have written this. Okay. Next, I am erasing this. Next, negative vector. Next one is negative vector. Negative vector. If a vector is there, a bar, and we want the negative vector of this, we have to just draw the vector in the opposite direction, and that itself is the negative vector. Okay. So a negative vector is the one which is having same magnitude but opposite direction. What is that? Same magnitude but opposite direction. That is the negative vector. Okay. Next, co-initial vectors. Co-initial vectors. Their initial point is same. So this is a bar and this is b bar. And one more vector is the c bar. So these vectors are co-initial vectors if their initial point is same. what I have to write here, initial point of these vectors is same. Note down this. Okay. Next we have coplanar vectors. Coplanar and endama. What is meant by coplanar? They are lying in the same plane. Okay. May not be co-initial. They may be lying in the same plane, but their initial point may not be same. If initial point is same, then we say that they are co-initial vectors. Okay. Next, last one we have coplanar vectors. Here on the top I will write coplanar vectors. Coplanar vectors means what? All vectors lie on the same plane. All vectors lie on the same plane. Whether it is xy plane, if this is the board and we suppose that this is x-axis and this is y-axis. And if I write the vectors like this, they are lying in the same plane. If they are lying in the same plane, then they are called coplanar vectors, xy plane. Okay? XY plane lo unnai kada ivanni vectors. I am thinking this has x-axis and this has y-axis. Okay? Shall I erase this? It's easy only, huh? Next, I'll just erase this, right? Next we have this multiplication of a vector by a scalar. What is the next concept? Multiplication of a vector by a scalar. Side heading, you can keep the side heading. Multiplication of a vector by a scalar, okay? Suppose we have a vector which is denoted like this, a bar, or you can keep the arrow also. And now if I have a scalar, if some m is a scalar, if I multiply this with the vector with m, so we got this vector as m into a bar. So, for example, m value is 5. This vector gets multiplied 5 times. Okay, this is, for example, this is a vector a bar, and if m is equal to 5, we have to draw a large vector. So this is getting multiplied by 5 times. This is nothing but 5a bar. I will write this as 5a bar. Okay. So this vector direction is not changing. If m is equal to -1, then the direction can change. Like this I have to draw. So here the magnitude of the vector is changing. Here 5 times it is changing, right? If I multiply a vector by a scalar, suddenly its magnitude will increase. Okay. Or you can take like this. So we have that concept of force. Force can be written as mass into acceleration. So this is a scalar. Okay. Mass is a scalar and acceleration is a vector. Right. Again we will be getting the vector only. We will be getting the vector only. So if we multiply a scalar with a vector, then ultimately we will be getting a final thing is a vector. Final product is vector. Okay. Note down this. If a bar is a scalar, there is a vector a bar. For a vector a bar, if m is a scalar, the final product m a bar is a vector, and the final product m a bar is a vector. M a bar is a vector. What about if two scalars are there? If two scalars are there, if m comma n are scalars, okay, and m plus n into a bar, how you can write? M a bar plus n a bar. You can write it like this. Okay. Just that a bar can be multiplied by this as well as by this. Okay. Next we'll go for addition of vectors. So what happens if you multiply a vector by a scalar? The final thing is again a vector. So momentum is there. Momentum is mass into velocity. Velocity is a vector and mass is scalar. And if you multiply both, again you will be getting a vector quantity. What is that vector quantity? Mass into velocity. It is nothing but momentum. Okay. When here it is mass into acceleration is nothing but force. Okay. So I am just erasing this. See, we will go for addition of vectors, then subtraction, addition, subtraction, and after that we will go for multiplication of vectors. Okay. So first addition of vectors. Addition of vectors. And then we can go for subtraction. Addition of vectors, there are three laws. One is triangle law of vectors. The first one is triangle law of vectors. And the second one is polygon law. And the third one is, important one is parallelogram law of vectors. Side heading, you keep the side heading now. So you have to write simultaneously with me. Okay. If two vectors, you have to write it, if two vectors represents the adjacent sides of a triangle taken in the same order, okay, then the resultant of these two, resultant means adding of these two, resultant of these two, new vector. So if you add two vectors, you will get a new vector. And the resultant of these, then the resultant of these two vectors, is the statement is only bigger, but easily you can understand. Is the closing side of the triangle taken in the reverse order. Closing side of triangle taken in reverse order. Okay. So you can easily understand this. This is a bar. There is a vector a bar, and there is one more vector b bar. I have to add these two. How I have to add is, first you take this vector like this. Don't change the direction and magnitude. Okay, this is a bar, and and now this is B bar. Okay, don't change the magnitude and direction. Direction is somewhat like this. Okay, this is B bar. And what is A bar plus B bar? Closing side of the triangle taken in the reverse order. I have to close this triangle like this. This is A bar plus B bar. Are you understanding? So if two vectors A bar and B bar represents the adjacent sides of a triangle taken in the same order, and the resultant of these two is the closing side of the triangle taken in the reverse order. You should not close it down. You should close it in the reverse way. Okay. Draw this diagram. చెప్పండి ఎలా చెప్తారు ఇది? If two vectors represents the adjacent sides of a triangle taken in the same order, the resultant of these two vectors, and if one force is acting like this and another force is acting like this on an object, resultant force will be like this. The body will move in this direction. Okay, one force is like this, another force is like this, the body is moving like this. This is the resultant. Okay, closing side of the triangle taken in the reverse order. It is going up, not down. Okay. We can understand in another way. If there are three vectors and these are forming the adjacent sides of a triangle taken in the same order, A bar, B bar and C bar, then what I can tell is A bar plus B bar plus C bar is equal to 0. Okay. If I am taking all the vectors in the same order and the triangle is closed, that means resultant force, resultant vector is 0. Okay, like this we will be getting. You take it note point. Okay. Next, this is the triangle law of vectors. Shall we go for polygon law? Okay. Polygon law. If there are more than two vectors, then we have to apply polygon law of vectors. Just I'm erasing this. Okay, Surendra. So polygon law is the law which we have to use if there are more than two vectors. If there are more than two vectors. Okay. So write along with me polygon vectors, polygon law of vectors. Polygon law, just polygon law you can write. Okay, this is for addition. If 3 or more vectors represents the adjacent sides of a polygon, represents the adjacent sides of a polygon taken in the same order, then the resultant of all these vectors, how we write? Resultant of all these vectors is the closing side. Resultant of all these vectors is the closing side of the polygon taken in the reverse order. Very easy, huh? We can understand easily by this diagram. So this is A bar and some B bar is like this, some C bar is like this. and D bar is like this. Okay, so I have to add all this. So first you draw A bar and you attach this B bar. Don't change the order, okay? B bar. Next C bar is like this you have to draw. Okay, this is C bar. D bar is like this. Okay, this is D bar. And what is the resultant of all these vectors? Closing side of the triangle, little small we can draw, same. Okay, this is the closing side. This closing side is nothing but, okay, that is the resultant. A bar plus B bar plus C bar plus D bar. Okay. So this polygon law can be constructed by using a triangle law. First, I will draw here one line joining this, one arrow. This is A bar plus B bar, na? According to triangle law. And this is the vector, and this vector I am adding C vector now. For this vector I am adding C vector. What is this? A bar plus B bar plus C bar. And if I add this with this, I will get this. Are you understanding how we got this? So from triangle only we can understand how we got this A bar plus. What is that? Ultimately what we are saying is, if all the vectors A bar, B bar, C bar, D bar are representing the adjacent sides of a polygon taken in the same order, okay, like this clockwise, this is clockwise, but this is anti-clockwise, taken in the reverse order. Resultant of all these vectors is the closing side of the triangle of the polygon, closing side of the polygon taken in the reverse order. You understood this? So this can be brought out by using triangle laws. Here you complete a triangle. This is one triangle and another triangle. Like that you can bring this, and ultimately you can prove that this closing side is nothing but resultant of all these vectors. Three or more vectors are there, then you have to go for polygon law. Understanding? Note down this. So this and this I join here, and this I join here, and this I join with C, taken in the same order. But what is the resultant? Resultant is the closing side taken in the reverse order. And a person is pushing an object like this, another person is applying force like this, and the third person is applying force like this, fourth person, and this is the way the body will move. Okay, that is the resultant. Okay, then we'll go for parallelogram law of vectors, very important. Okay. Okay. Sorry. Just I am erasing this. So you can take three or more vectors. That will become a polygon. Okay, polygon law, not triangle law. Triangle law of vectors means we can only find the resultant of two. Closing side of the triangle taken in the reverse order. But what about polygon law? We can take more vectors. So they forms the adjacent sides of the polygon taken in the same order. Resultant is closing side of the triangle taken in the reverse order. So next one is the last one here. In addition, parallelogram law of vectors. This is important, okay? Parallelogram law. Okay. So there are two vectors forming the adjacent sides of the parallelogram drawn from the same point. This is A bar and this is B bar. Okay, I have to find the resultant of these two. So one boy is applying a force like this, another boy is applying a force like this. Then what is the resultant? Okay, what you have to do is you have to complete the parallelogram. how we can complete the parallelogram? So draw an equal vector here, equal vector that you name it as a bar only. Direction should be same, okay, and magnitude also should be same. This is a bar, and one more vector here, b bar. So I completed the parallelogram now, okay, and let theta be the angle between the two vectors, okay. Now first I have to find the magnitude of the resultant. What I have to find magnitude of resultant, and then I have to find the direction. First I will do the magnitude part. Koncham fine rastane. I will find the magnitude first, and then vector it will also have direction. So parallelogram law of vectors is can be given like this. If two vectors a bar and b bar represents the adjacent sides of a parallelogram drawn from a point, okay, then the resultant of those two vectors is the diagonal of the parallelogram drawn from the same common point. Actually parallelogram there are two diagonals. This is one diagonal and this is one diagonal. This diagonal we have to take, okay. This is a bar plus b bar, okay. From triangle also you can understand that this is a bar, this is b bar, and this is a bar plus b bar. This is correct only, na? So in parallelogram law of vectors we say it is the diagonal of the parallelogram drawn from the same common point, okay. Write down statement first. Statement: if two vectors a bar and b bar, right nama, if two vectors a bar and b bar represents the adjacent sides of a parallelogram, represents the adjacent sides of a parallelogram drawn from a point, then the resultant of these two vectors is the diagonal of the parallelogram drawn from the same common point, okay. So I have taken a common point O here, and this is OA bar is nothing but A bar, and OB bar is nothing but B bar, okay, and OC bar is the resultant. So I have to find the magnitude of this and direction also. Let here this resultant is making angle alpha with A bar. What are our assumptions? Let theta be the angle between A bar and B bar, okay, and alpha is angle made by, what is this? Angle made by resultant. Resultant means A bar plus B bar, with A bar. Okay, these are the two assumptions. Alpha is the angle made by A bar plus B bar with A bar, okay. So I have to tell the alpha value also, because I have to tell the magnitude of the vector as well as direction also. Direction is given by this angle. If I tell the angle, then I am telling the direction of that vector. Okay. Next. So for finding the magnitude, what I will do is So you have written this now. So this b bar I will take here inside, and I will extend this vector little bit forward, and I will drop a perpendicular here. I will drop a perpendicular. So as these two vectors are parallel vectors, this angle is also theta. Okay, and this point is D, where we have that perpendicular. And what is this AD? What is the magnitude of AD? What is this CD? We have to find this AD and CD. So first AD we will find. Cos theta is adjacent side by hypotenuse. Hypotenuse is B. Here modulus of A bar is A and modulus of B bar B and తీసుకుందాం. The magnitude of B bar is B. Let it be B. Okay. And what is the magnitude of A bar? It is A. Okay. That is also our assumption. So what is AD then? AD is B cos theta. And similarly I can write CD as B sin theta, because sin theta is opposite side by hypotenuse. So this CD is nothing but B sin theta. Okay, now I have to find the length of this vector OC. I have to find the length of OC. Are you seeing a right angle triangle, big right angle triangle? Yes, we are able to see the triangle OCD. In triangle ODC, let us write like this. D is the right angle, okay? We have OD square plus CD square is equal to OC square. I have to find OC. What I have to find? OC I have to find. That is the magnitude, OC. Okay, OC square, I can write it as, what is OD square? OA plus AD kada? OA plus AD whole square plus CD square, okay? This I can expand. OA square plus AD square plus 2 into OA into AD plus CD square. A plus B whole square place, and then I have just taken A plus B whole square. OA square means A square, okay? OA square means A square. AD square means B square cos square theta. B square cos square theta. And OA means A, AD means B cos theta. And what is CD square? CD square, B square sin square theta. So here B square sin square theta is there, here B square cos square theta is there. B square if you take common, okay, what is that? B square into sin square plus cos square? It is 1 plus 2AB cos theta. So this, if you want OC, 1 minute. What connection first? Okay. So up to here I can write. So this is OC square. OC square. What is OC then? OC is root over A square plus B square plus 2AB cos theta. So because with the same name other students also will be there, na? Okay, it is a request from our side, right? అదే ఇంటి పేరు కూడా టైప్ చేయండి నెక్స్ట్ టైం లాగిన్ అయినప్పుడు, ఓకే? రైట్. Now we are understanding this parallelogram law of vectors, okay? What is this? Ultimately we got this as root A square plus B square plus 2AB cos theta. So that is the magnitude of the vector resultant. So tell what is the magnitude of the resultant if A bar and B bar represents the adjacent sides of a parallelogram drawn from a point, and this is the length of the diagonal. So in the exam, theta will be given. Theta means angle between two vectors, and magnitude of both the vectors will be 3 newtons, 4 newtons, and both are at an angle 60 degrees to each other. And what is the resultant? Root over 3 square plus 4 square plus 2 into 3 into 4 cos 60. You can write it like that. Okay. Right. And this is the magnitude of resultant. Cheppandi formula cheppandi. Root a square plus b square plus 2ab cos theta. You can remember the formula. No? What happens if theta is 0 degrees? Cos 0 is 1. Na? Cos 0 is 1. Root over a square plus b square plus 2ab you will get. That is a plus b whole square under root a plus b. If two forces are acting in the same direction, that is theta is 0, then directly you add those two forces. 3 plus 4 is 7 newtons. Okay, two forces. And if theta is 180, what we can do? Cos 180 is minus 1. Cos 180 is minus 1. Here if you will be getting minus a minus b whole square under root, you will be getting a minus b. One force is acting like this, another force is acting like this, just in the opposite directions. For example, this is a pen. I am applying the force like this, opposite forces. So resultant force is what? A minus b. Here theta is 180 degrees. Cos 180 is minus 1. Okay, minus you will be getting here. And what is the root a minus b whole square? Root a minus b whole square is a minus b only. What about if theta is 90 degrees? Theta 90, cos 90 is 0, na? Cos 90 is 0. So what is the resultant? Resultant is nothing but root a square plus b square. If one vector is 3 newtons, another vector is 4 newtons, resultant is root over 3 square plus 4 square, perpendicularly if they are acting. Okay, whatever the angle, but you can keep it here, cos theta. So I have derived the magnitude of resultant. So then I have to derive the direction also. This alpha I have to tell. Okay, first you note down this. Okay, ma. Over kada, easy na? Is it easy? It's a very important 4 marks question. So one more thing is there is a change in some IP rules that you have to read the entire textbook. There are no previously this used to be the important question, parallelogram law of vectors, 4 marks for IP. But now they just want to change the rules that whatever it is done in CBSE board, they want to bring it here also. So no questions on the back of the lesson. You will not be giving the questions on the back of the lesson. Entire lesson you have to read, and from within the lesson they will give some questions. Okay, this may be implemented, but it is difficult only. Okay. So you have to read the entire textbook, right? And but if you get this, almost all the vectors, everywhere we will be getting vectors, na? Along with scalars you will be getting the vector quantities also. If you want the resultant, certainly you have to go with parallelogram. In that way it can be important, not only in a board exam. Okay, everywhere where we are dealing with vectors, you have to remember this parallelogram law of vectors. So this is the magnitude. Okay, then if I erase this, I can go with the direction. How you can find the direction of this vector? Okay. This will be asked as a 4 marks question. Okay. Direction also you have to write. Easy only. Okay. What is this AD? AD is B cos theta. What is CD? CD is B sin theta. Then this is OC square is OD square plus CD square. OD is nothing but OA plus AD. OA plus AD whole square. Okay. OD square. OA means A. AD means B cos theta. And CD means, what is CD square? CD square what I wrote? B square sin square theta I wrote. And here B square if you take common, cos square plus cos square, sin square is 1. Okay, then I will get OC. That is the magnitude of resultant. Okay. I am just erasing this. So what is the formula? Root A square plus B square plus 2AB cos theta. And let us go for the direction part. Okay, you have to derive the direction also. Direction is easy one. Easy derivation is easy only. Okay. What is this direction? Direction of resultant. Direction of resultant. Okay. This is tan alpha. Tan alpha is equal to opposite side by, what is this triangle? ODC, right angle triangle. Right angle triangle, big triangle are you seeing? ODC, this big triangle. Tan alpha is opposite side by adjacent side. Opposite side is CD, adjacent side is OD. And CD by OD, how I can write? OD is OA plus AD. OA plus AD. Okay, CD is nothing but what I have written previously, CD. B sin theta, B sin theta. Chapter B sin theta divided by, what is OA? OA is nothing but A. What is AD? AD in the game chapter AD. B cos theta. What is that? AD is B cos theta. Then what is alpha then? So alpha is tan inverse B sin theta divided by A plus B cos theta. You have to remember this formula. Okay, this angle is made by the resultant with A bar. With A bar. Okay. If he asked what is the angle made by the resultant with B bar, then you take here A sin theta by B plus A cos theta. You can reverse it. So in the exam, if angle made by the resultant with A bar is asked, then this is angle. Alpha is equal to, tell the formula, tan inverse B sin theta by A plus B cos theta. Okay, that is with A bar. With B bar, if he asked, with B bar adite, with B bar adite, A sin tan inverse A sin theta by B plus A cos theta. Okay. Okay, then if theta is 90 degrees, theta 90 aite, what is if theta is 90? Cos 90 is 0 and sin 90 is 1. Tan inverse B by A you will be getting. Tan inverse B by A. If theta is 0, sin 0 is 0, alpha will be 0. Theta 0 means one vector is acting like this, another vector is also acting like this, the same direction. Then resultant will be also in that direction only. Okay, in the direction of A bar and B bar. If both angle between both of them is theta is 0 degrees. If theta is 0 degrees. Okay, note down this. This is the direction part. This direction part is easy only, na? It is easy, kada? Okay, random. Note down this. Let us do few problems on this. Okay. What about subtraction? Subtraction of vectors kuda undi kada. We will go for subtraction also and then we will go for problems. This is these three are the laws in vector addition. First one is triangle law, polygon law, parallelogram law. Three laws. Okay, fine. We'll go for subtraction of vectors, right? Arrest chestane. So now if you are telling the angle made by the resultant with a bar, then you are telling the direction of resultant. Okay. Resultant vector has both magnitude and direction. So now you told about direction also. Okay. Now what about subtraction of vectors? How we can subtract two vectors? So subtraction of vectors. So I need to subtract two vectors. A bar is like this and B bar somewhat it is like this, B bar. And I have to subtract these two vectors. What I need to take is, I have to take the negative of this vector and add with this. So this is A bar and negative of the vector will be just opposite in direction but same magnitude. Minus B bar ila untadi. This is minus B bar. Okay, only direction we need to change, not the magnitude. Length is same. Okay. This is minus B bar. And this vector is A bar minus B bar. Closing side of the triangle taken in the reverse order. This vector. Okay, this is A bar minus B bar. Okay. Write down the statement. If two vectors, one minute. A bar and B bar can be subtracted by adding the first vector with the negative of the second vector. Okay. Write down two vectors are said to be subtracted. Two vectors are said to be subtracted. Are said to be subtracted if we add the first vector. If we add the first vector with the negative of the second vector, okay, so take this example. This is A bar, this is B bar. I have to subtract this from this. First I have to take minus B bar, this one. Opposite arrow I have to draw. And this is the resultant. Draw this. So 1723753 is your ID, it seems, huh? Okay. I'm seeing there means there is the desktop. So here is the camera and there is that monitor. This is what webcam, no? This is webcam I am seeing. Okay. And nowadays I am getting big monitors we are getting. At a time I can see all 25 of you. Now only 19 members are there. Okay. I can see all of you. In the cell phone it is not possible. Only 4 we can see at a time. Okay. Might be some of you are having the system. They can listen from that. Okay, I can erase this. Cell phone kuda vedikpotuntade. Charging also it is very fastly it is complete because this is video conferencing, na? So charging also per one class 30% charge. Somebody said that. Surendra said that 30% charging is getting finished. Okay. And what about? So still some part of this is there. Subtraction of vectors. Tomorrow we'll continue. Okay. Right. I think for today this all your classes are completed, it seems. Okay. From tomorrow I will give the homework part. Just half an hour. Okay. From your side. Okay. Bye. Take care.